As we saw from our shapes taped to a stick activity, if we take a two-dimensional figure and we rotate it around an axis, we're going to generate a three-dimensional figure called a solid of revolution. The three-dimensional figure formed by spinning a two-dimensional figure around an axis is called a solid of revolution. So if I take this rectangle and rotate around the axis, we said that that makes a cylinder. We get a cone from rotating the triangle around an axis, and we get a sphere from the semicircle. So let's take a look at pictures for each of these, and let me encourage you to draw and label each of the different parts. For a cylinder, we have two congruent circular bases, sort of like a prism, but of course a prism has polygons. And these things are parallel to each other. And you can see right here, if we join the two centers, that looks like the axis that we spun this rectangle around. And not only that, this top edge or the bottom edge, that would be the radius, and this is going to be the height for that cylinder. If this axis here is perpendicular to the base, then we have ourselves a right cylinder, and that will be the same thing as the height. And this edge over here would also be the same thing as the height of that cylinder. Let's look at the middle picture for the cone. And in the cone, we just have one circular base, and directly opposite from that circular base, we have a vertex. So this one's very similar, of course, to a pyramid, which has one base and a vertex directly opposite from it. You can see traced out in here with the radius and the altitude that it makes a right triangle. It's the same right triangle that we used to generate that figure. This would be the radius of the base. This would be the vertex up here. This would be the height of that cone. And the slanted one is, of course, the slant height. It's not labeled here, but it will be on the next picture. Okay, and then just like with the cylinder, we can have right cones and we can also have oblique cones if this vertex point was sort of over here instead of directly in the middle. And then lastly, we have ourselves a sphere. And for this particular sphere, we got the radius labeled. This radius would be the same radius length as the semicircle that generated it, and then straight up and down we would have the diameter. We can get the diameter again, same exact way, or, and we have a center point. So another definition for a sphere is that it's the set of all points in space that are equidistant, the same distance away from a single point in space called the center point. We can find the center point on here because it would just be the middle point or the midpoint of that axis, right about there. Okay, so one of the things that we're going to have to do with these shapes, of course, is find the surface area. And for a cone in particular, we need to be good about distinguishing the difference between a height and a slant height. So let's take a look at these. By convention, we're going to use the letter H for height, and we're going to use the letter L for slant height. So think of it as the letter L that's in the word slant. And those two things have a very particular relationship, and it's the same thing on a pyramid as it is on a cone. So the height is the same thing as the altitude here, and this one is making a right angle with the base because it is a right pyramid. Same thing with this right cone here. It's the altitude. It makes a right angle with the center of the base. All right, and then the slant height on a pyramid is the height of one of the triangular lateral faces. For a cone, it's just the slanted edge here. That's the slant height. And what we said back over here on the pyramid is that it makes a right triangle, especially if I were to draw in this segment that connects these two down at the bottom. So you can see very obviously on this one, it's the radius that forms the base of that right triangle. On here, you could kind of call this thing the radius, but it's not called a radius whenever it's a polygon. This has a special name. It's called an apothem, and we'll talk about that word in a future lesson. But for right now, know that we make a right triangle using a slant height, a height, and the radius for a cone. So if we're missing one of those and we need it for the calculation for surface area, we can relate those with the Pythagorean theorem, a squared plus b squared is equal to c squared. And then in this particular case, our a and our b are going to be the radius squared plus the height squared should be equal to the slant height squared. All right, these solids of revolution, very important in calculus, if you're fortunate enough to take calculus before you leave high school here. So instead of taking, let's say, something as simple as a rectangle and rotating it around an axis, we're going to take a function and rotate it around an axis. This function, very strange. We got f of x is equal to the square root of sine x. I'm going to rotate it around the x-axis, and we're going to generate a three-dimensional solid. And one of the things that calculus will ask us to do is to find the volume or the surface area. And here's what that shape would look like. And specifically, the way that we think about it is based on what we did right here. It's based on this very simple idea of taking a rectangle, rotating around an axis, and it generates a cylinder. And to find the volume in calculus, we do the exact same thing. It's called the disk method, because we're going to break it up into little rectangles, and we spin those rectangles around an axis, and it's going to make a little cylinder. And all we'd have to do, and what calculus will allow us to do, is just add up a whole bunch of those cylinders to get closer and closer to the volume of that particular shape.